Next we do exercise 7. Here we are gonna learn another feature of Minitab. According to a Google search, the average height of male soccer players in the US is normally distributed with mean 1.79 meters with a standard deviation of 0.04 meters. The question is, for a randomly selected soccer team of 11 players, what's the probability that the average height of the players is less than 1.77 meters? Calculate the probability by hand or Minitab. So we are going to do this first by hand, and then I'm going to show you also how to do this in Minitab. So here we are going to represent X as the heights of US male soccer players, and it is given in the question that X is normally distributed. It's given here. So X is normal distribution with mean mu is equal to 1.79 meters, and standard deviation is given as 0.04 here. Okay, so I can highlight actually. Okay, mean is this and standard deviation is this. Okay, this much. Okay, and we know that it's normal distributed. It's given in the question. Since X is normally distributed, we say that X bar is normally distributed too, and the mean of the distribution is going to stay the same. Okay, standard deviation is going to be computed divided by square root of 11. 11 is the number of players. Okay, there are 11 players. These are randomly selected soccer team players. Okay, then so we found the sigma X bar. So we want to determine the probability by hand first. We are interested in probability of X bar being less than 1.77. This is equivalent to probability Z, so we have to normalize this. So X bar is not standard normal. X bar is normal but not standard normal, but we have to convert it to standard normal. Therefore we have to subtract this 1.79 and divide by the sigma of X bar. Yeah, okay, this is mu X bar, this is sigma X bar, and then this is equivalent to probability Z less than, strictly less than, negative 1.67. So we go to Z table and we get that this is equal to 0.0475. Now how would you do this on Minitab? So there are some steps and I'm gonna share them with you here as well. So we are gonna go to this graph button, and from this graph button we are gonna go to not probability plot but probability distribution plot. Okay, we are gonna go to distribution plot, and then we are gonna choose there's view single, vary parameters, two distributions, view probability. So we are gonna choose view probability and we are gonna click OK, and then from here for the distribution we are gonna choose normal. Okay, because we know X bar is normal, and then the mean is 179 and the standard deviation is 0.012. Okay, and we are going to also select the shaded area. In the shaded area we have probability option, we have X option, so we are going to choose the X option. And if you look at the question, okay, we are interested in X bar less than 1.77, so this means this is the left tail, so we have to choose the left tail according to that. So this is right tail, this is right tail, this is left tail, both tails, middle tail. So we are going to choose the left tail, and the X value that we want to find is 1.77. When we click OK, we get the distribution plot, and in this graph we have all of the information. This is our normal curve. This is the value 1.77. This is the area, which is the probability for x bar less than 1.77. Okay. Alright, so here mean is 179, standard deviation is 0.012, and the area of this shaded region is 0.04779. So this is exactly the same result that we get when we do this by hand. Okay, almost, because these are almost equal to, yeah, because of that. That's the case. It's almost equal. So this value, okay, and this value almost the same. Okay, so let's continue with other questions in this problem. So in question B, in view of the small sample size, must you make any additional assumptions to justify the answer to part A? Please provide a short explanation. The answer is no. The reason is we already know the distribution of x is normally distributed, normal distribution. Hence x bar is also normally distributed. Therefore we don't need to make any other assumptions. Question C, set up the hypothesis test to test the true average height of male US soccer players. So we are interested in, we want to check whether the mean is less than 179. Yeah. So our null hypothesis is going to be mean equals to true mean equals to 1.79 versus alternative test, which is true mean less than 1.79. So we are going to go down a question D. Determine the z statistic and p-value for the hypothesis test in part C. The z statistic and the p-value. The z statistic was already found. Okay. Part A, let's go back to part A. Part A. Okay, the z, this is the z value actually, right? This value, which is negative 167, is the z value. And then what's the p-value? P-value is actually, this is the p-value. P-value definition is probability of x bar less than this required 177. Okay, so we already found p-value. We don't need to do anything else. Okay, that's it. This is the end of the question.